Alright, well, I just tried putting this chip in that was on this side over here, because this is the side I've got the scale plugged into, and it's pulling everything low again. So now I'm going to try the other one. That'll do it. Alright. Yeah. High state of 0.391 volts, not even a half a volt. This is completely theoretical, but I think that what has happened is I think that both of these microcontrollers have problems internal to the chip that are effectively shorting out the inputs and keeping them all in a low state. Try this one more time. Just in case I mixed these up when I was playing with this thing. I can see right there, it's same as it was before. I can't think of any reason why which side it's on should make a difference, but just for the hell of it. Boy, this one certainly seems to be not doing. That's the same. Lousy. So guys, that's my theory right now. My theory is that that there's something wrong with the microcontroller chips, and because when I have the microcontroller chips unplugged, the encoder seems to be outputting something. High volts, the 5 volt, the state of the output pins, the 4 output pins on the encoder, go high to 5 volts or low to 0, depending, and different combinations depending on which combination of X and Y's I short together, which is exactly what I would expect the encoder to do. But they didn't appear to be changing much at all, but that's because for some reason that voltage coming out of the encoder is being sucked down, pulled down by those microcontrollers. So I'm leaning towards the microcontroller chips being bad. Now, I found the microcontroller chips on eBay. I actually ended up ordering them initially, and then within like a half hour of ordering them, I was reading online and came across some information on that particular controller and realized that I better cancel the order, because this is what I found out about this. Now, this is the information I garnered off the internet, which is leading me to believe that I can't just buy one of these chips. To refresh everybody's memory, in case you haven't been following along with this is a MOSTEC MK3870/20 microcontroller. Okay, MK3870/20. You can actually get the datasheet online for this still. Microcontrollers have to be programmed, okay, to do the job that you want them to do. So at the factory, this was programmed. My understanding is that the read-only memory on this chip is what's called masked ROM. M-A-S-K-E-D ROM. And my understanding is that the actual programming of this microcontroller takes place during the manufacturing process, and that this microcontroller cannot be reprogrammed. So, you can't just buy another MK3870/20, which there are several people selling them on eBay, and expect it to plug in and do anything in this thing. Because what if the MK3870/20 that they're selling was programmed to, I don't know, run a digital clock in an old microwave or something? Who knows? So if anybody has any information, you know what? I just unplugged this while it was still on. Probably shouldn't have done that. Oh well, yeah, like what am I going to do, hurt it? So if anybody else can, give me any more information, or, if you think I'm right about that chip not being replaceable because of the fact that it's programmed at the factory, please let me know, because if I'm wrong about that, well, I mean, even if I could program it, what the heck am I going to do? I would literally have to buy the chips, the good chips, assuming that I'm right and these chips are bad. I'd have to buy the good chips. Then I'd have to get them here. Then I'd have to literally build a circuit and program the chips. And here's the rub. I don't know what the program was. So how the hell am I going to program this thing? How the hell could I program a new chip? Because that's the other thing too. There might be another chip out there that has an EEPROM on it, that has the same pinout and would do the job of this chip, but has a what they call a piggyback EEPROM, like an outboard memory chip that allows you to actually change the programming on it. Again, got to be able to read the program of this chip first, and you can't read the program of this chip if the chip's bad. So there she lies. Paperweight. The only question left to resolve would be whether or not I could actually repurpose these glass scales with a different DRO. So that's something there, because like these guys who are making these Bluetooth DROs, that they're using like a cheap tablet and software, and they're basing it on, I think, what they call the Arduino chip design or something like that. I just barely started reading about it, but basically that you're making a controller, or a I forget what they call it, an encoder that can read magnetic or glass scales depending on what you have. Well, maybe I could make an encoder that would read these glass scales that I have and work with that software. I don't know. It's all way above my pay grade. All right, but I think that's going to be it for this. Hey guys, it's a day later, and I just couldn't bring myself to throw this thing out or give up on it completely. So I came down here earlier today and was messing with it again, and I made some progress. And so I actually undid the progress I made because I wanted to show you how it was just a complete, almost like a blind troubleshooting hunt and peck method that got me to the point where I was. So first thing I did was I fired up the soldering iron and I just hit a whole bunch of solder connections. I hit like every solder pin on the socket for the microcontroller. I left that microcontroller out. Soldered a few around the clock circuit components. I scoped the clock circuit, and while scoping the clock circuit and observing the waveform, I used freeze spray, circuit refrigerant, and cooled several components to see if anything would change. I couldn't get anything to really happen. Then I decided, I went back to this whole thing with the clear button and everything, and I was wanting to figure out whether or not this matrix even worked. And I said, well, that should be easy enough to determine. So I plugged in the cables for the matrix here, and then what I did, I'll show you, was to fire it up, and of course it still got the same thing, got 1 decimal point, whatever. What I did was I took the meter, my scope actually, and I set the scope so that I could view the DC voltage So that's 0 volts, 5 volts. And I looked at this pin that is the data out pin, which is, data available pin number 12. So that's this pin here. And what I did was I pressed the button. And notice when I depress the button, the clear button, it goes, that data available pin goes high to 12 volts. So, and pretty much any button I tried, I could get that to happen, which tells me that this matrix is working. So then I started to look at the pins here, the output pins, which are pins 14 to 17. So, just for the heck of it, randomly pressing, nothing on 17, nothing on 16. Notice that pin 15 is high. Well, if I press the right combination of buttons, it goes actually, there we go. I hit the 0, pin 14 goes low. I hit the clear, it goes back to high. So this is actually working. So I was like, well, that's interesting. So then I was like, well, if that's accepting commands, I wonder if anything else is happening. And I noticed that when I would press the 2 button, a segment partially lights here on the LED. So there you go, 5. You can see now I've got another segments here. And so I can get partial segments to light, and then when I hit clear, it goes back to pretty much nothing really. Well, actually, it's kind of, I don't know if you can see it, but it's actually kind of dim. So it's the bottom one here. I mean, I don't know if that's showing up or not. Need a third hand. Let's see if I shut this off. Maybe it'll show up better that way. So there's a segment right there that just hit the clear button and it goes out. Something's going on. So I was like, well, okay, that's interesting. So then that got me to thinking, maybe I'm back to a driver problem. And that it's not that the thing's not working, it's just that I'm not seeing what it's doing because of a driver problem. So what I did was I decided to try and switch out the driver ICs. So there's one IC here and one IC here that are the driver ICs for this channel, and these 2 ICs are the driver ICs for the channel that's not being used right now. So just for the heck of it, I pulled this chip, which is a 2204CP. 2204CP is the chip number. Okay, so just for the heck of it, I pulled that chip, and I pulled this 2204CP from the channel that's not being used, and I put that chip in this location. Okay, put that chip in this location, fired it up, no difference, right? Then what I did was I hit the clear button. Ta-da! And boy, did I get excited when all those zeros popped up. Then I moved the scale. And son of a gun, if it doesn't work. So, how do you like them apples? So I think it's safe to say this chip is bad, and this little 8-pin chip is 2204 CP. I haven't looked it up yet, but I bet you that can't be a very expensive little chip. So it's working. So what I want to do now is I want to shut it off. I want to put that microcontroller in this location, because now I know this whole channel's working. So I should be able to swap this microcontroller with that one, and if it still works, then I know both my microcontrollers are good. So sadly, it appears this microcontroller has a problem. And that makes me think that if I had these swapped, I never would have just gotten that lucky and found that pulling that one chip fixed it. And again, if I put this chip in, go back, clear, all zeros come up, and again. So I got a DRO with only one axis that works. Bummer.